all the students of the Department of Computer Science. So today, the Department of Computer Science, Ramkrishna Mission, Vivekananda Centenary College, Rahara is organizing a seminar on towards quantum intelligence. So first of all, we are very much thankful to our Principal Maharaj to organize such an important seminar. So now I am requesting to our Principal Maharaj to felicitate our distinguished guest, Dr. Omlan Chakraborty. So we are now requesting our Principal Maharaj to deliver his welcome speech.
So, most respected Professor Omlan Chakraborty and my dear colleagues and my very dear students of Computer Science Department. So, today we are here to hear about the talk what Dr. Chakraborty will deliver. And it is a very interesting topic. Sir actually the director of A.K. Chaudhary School of Information Technology, Calcutta University. But before that he has a vast background in corporate world. Now he is in teaching field. So he is a person of versatile, vast knowledge of corporate world as well as teaching field. And now he is the in charge of government of India, so many projects, and very now the emerging project I think all you have seen. I do not know how many have heard. I first read in newspaper. He is now the in charge of the West Bengal government this project, that is excellence in AI and data science. How many have heard? Raise your hand. Oh, okay, very good. I thinking that nobody have listened her just. So so you can understand his knowledge domain. Government actually given right person the right duty. So he's not only a good teacher, but he has a great corporate world background. So for this perspective, his discussion regarding this AI and its future perspectives, I think it will be a great help to you, because he is very competent in this field. And I request all the student, you listen all his talk, because he is a good teacher. Your one or two elder brothers, means the your predecessor, they are actually working with sir lab. So sir also told that he is a good student. So in future you also can get chance for internship, but condition you have to prove it. You have to prove it, because we cannot recommend any student to sir that you can go there to do internship. You have to prove that yes, you are capable to do this. If you can prove it, then I can assure in front of sir, and sir also like the good student. So with this few words, I tell students specially, you after the talk, you please interact with him. that sir, what is are telling? I could not understand this, because he's a teacher overall. So if you interact with him, I think it is a good gesture for our gathering. Otherwise, not it is. I could not expect that you just sitting and just dodging or somehow wasting the time of 1 hour. I do not like this. So I request each and every second you utilize, because I know that whatever he will tell, every word sentence will be knowledgeable to him. So I do not spend the time too much. I once again welcome sir and express my heartiest regard to him for coming over here. Actually he come here to attend a meeting of our board of studies, and he also agreed to deliver this talk. So with this few words, once again I once express my heartiest regard on behalf of all department faculty and also you, and I request him to deliver his talk.
Okay. Thank you very much, our principal Maharaj. Just going to the entire program, I am just going to briefly about the entire thing like that is our guest Dr. Pramlan Chakraborty have completed. He is a professor and the director of the A.K. Chaudhary School of Information Technology at the University of Calcutta. He is also the former Dean Faculty of Engineering and Technology of his university during 2016 to 2019. He completed MTech from the University of Calcutta 2001 and did a postdoctoral fellow at the School of Engineering, Princeton University, USA during 2011-2012. He has almost 20 years of experience in engineering education and research. He received the DST Boys Boys Cast Fellowship Award in Engineering Science 2011, Indian National Science Academy INSA Visiting Faculty Fellowship 2014, JSPS Invention Research Award 2016, Iramas Amanda's Leaders Award 2017, Hamid Visiting Professorship from University of Cambridge, UK 2018, especially Shiksha Ratna Award by Department of Higher Education, Government of West Bengal in 2018, and IBM Quantum Researchers Awards Access Award in 2021. He has received multiple projects grants in the areas of embedded systems design, VLSI design, quantum computing, computer vision, cyber security, IoT from funding agencies like DST, MEITI, DRDO, DAE, Ministry of Social Employment, UGC, TCS, India, Intel India, etc. He has also served in various capacities in various higher education organizations both at national and international levels. He has published around 160 plus research papers in referred journals and conferences, 4 patents and 1 copyright, and have graduated 16 PhD students till date. He is an associate editor of the Elsevier Journal of Computers and Electoral Engineers, series editor of Springer Transactions on Computer Systems and Networks, and guest editor of the Springer Journal of Applied Sciences, etc. So we are very much thankful to getting such important person with us for few hours. So now I am very much, I am talking, sir, please come to here and say something about this seminar. Thank you, sir.
Yeah, so very good afternoon to all the students. Thank you, Maharaj Principal Sir, and thank you, the coordinator of this computer science department, Maharaj. So my dear students, right, that means I know some of you because some of you visit my department, right, and interact with me. One of your senior past out student is also now a student of Calcutta University, computer science. He interacts with me very often, and he was also working with me when he was a student here, Shayun. Okay, so I am getting very good students here, and I have a very good, what I can say, I have a very good thought about this particular institute. Okay, because I believe that these institutes are really really institutes where you can actually practice learning. So learning is a practice, right? And the practice shouldn't stop, right? Once you stop the practice of learning, you are not a student, you are not a teacher, okay? And a teacher is always a student, right? Okay, we also have to learn. It's not that being a teacher, being a professor, we stop learning. We are also trying to learn, but we try to learn in different way than what you, because you have to learn the fundamentals, okay? We at your age focus on fundamentals. Fundamentals are whatever we do, quantum computing, 5G, parallel processing, high performance computing, right? Whatever we do, right, in life, right, in computer science or technology or science, right? Ultimately, the fundamental knowledge works. Okay, all fundamental knowledge can be stretched and can be extended, okay, to those particular hi-fi technologies, right? And this is the right time in your college, right? In a very good college, one of the top-rated college in our state, in our country, right? You are very lucky, okay, to get a seat here, right, and do this particular BSc Computer Science course. Now, right, obviously, computer science is now the what I can say the most most sought about subjects among the students. Okay, be in engineering, be in science, right? If you see the seats in engineering streams, right, the engineering colleges are opening various computer science courses. Okay, right. Okay. The other streams are getting a little bit less students. Similarly, in our undergraduate courses also, undergraduate science courses also, right, we see that there is a enormous that is the students are interested, right, to get into the computer science course. Now the thing is, this is good or bad? This is good or bad? Who can answer? This enormous focus on computer science in the student level. Okay, I'm interacting with a maybe I will interact for 5-10 minutes and then I will go to my talk and I will finish in 20-15 minutes. Okay, so let's try to understand that this enormous focus on computer science, right? Okay, whether it is good or bad, or it is that means okay, it makes life easier for you or life tougher for you, being the students. Tough. Why tough? Good answer. Why tough? Yes, because you have a lot of students at their computer science. That means আমরা বাংলায় বলি যে এখন আমরা বাংলায় বলি ঢিল ছুললে মেশিন লার্নিং এক্সপার্ট পাওয়া যাবে। হ্যাঁ, চায়ের দোকানে মেশিন লার্নিং পাওয়া যাবে, ঠিক আছে? মানে দ্যাটস দ্য ওয়ে মেশিন লার্নিং হ্যাজ কাম আপ, রাইট? Everybody has stopped everything and now doing machine learning. Whatever they either they know or don't know or trying to know or they know very well, right? Okay, everybody is doing machine learning now. So similarly, computer science has also come up in this particular way that everybody is doing computer science course. The computer science course has been stretched in different forms. Okay, but the advantage is that computer science also gives you to exposure to some of the very upcoming technologies. Okay, like why people are towards computer science? Because the computer science has progressed in a very fast pace, right? Others engineering have also progressed, but for that you have to invest a lot of equipment costs, right? In computer science we can use a cloud, right, and we can do a lot of computing without having the infrastructure at my place. In all other engineering or science, you require the infrastructure to be in your place, and that's why it is becoming very tough for the academic institutions to keep the pace in those particular subjects in basic science or basic engineering, right? But still computer science, we can make the subjects very good, we can improve the subjects, and we are making all the subjects which are required. Like that means in this syllabus of your college where I am a BOS member, we have incorporated lot of subjects which are cutting edge, because we know that there will be resources available. Computing resources will be available in some way, right? And students will able to access those, right? And there are enough faculties from industries and from research consortia who can help the students to get into this. Okay, and that's one of the way the quantum computing came in this particular college. I tried to push the students a bit, right? I think computer vision, Vishwajit is also driving computer vision. So these are some of the things which you have to take, because computer science have so many attractive domains now. Okay, each of the domains, if you see, right, if you see text analytics, so interesting. It is just text analytics. People were only thinking that NLP will be that means NLP is only the start and end of text analytics. Suddenly LLM came, right? In the, I think the last 2 years, and now it is heavily there everywhere. And now in any conference you see that people from other domains are trying to exploit LLM. Because LLM is such a particular model where you can actually, okay, train a particular corpus, okay, make a sort of, okay, make that particular system a helper to your process, right? It can be a query and you can get an answer. So this thing is possible because computer science has come up and that particular thing has been there. Like if you see computer vision, where we actually walked along in our, if you look into my research and my lab, I have graduated, I think almost including Vishwajit, who will be graduating very soon. It will be around 5-6 students have graduated with me in computer vision. But now computer vision is getting into a new direction, right? Computer vision is getting a sort of direction where the frame rates are pretty high now, resolutions are pretty high now. We are going to VR type of stuff, okay? We are doing the 3D videos, right, for the biomedical and other. So there are things which are moving up in very, very high scale, right? So these movements and this type of activities, okay, both in research and in industry, right, for that, right, we require a lot of students. Okay, say quantum computing, IoT, right, high performance computing, okay, these are the new age computing paradigms, okay, where the students should get trained. Okay, now what are the challenges? The challenges is that you need to learn not more now. Okay, the way we used to learn, we are very relaxed, okay, because the things were not pretty top heavy. Okay, we were in the bottom mostly. Okay, but now the things are very top heavy. Okay, right. And when you start, you are at the bottom when you are in the college, but you have to come up into that level, okay, so that a person can identify you as a maybe a good parallel programmer, maybe an HPC, or maybe a computer vision guy, maybe a text analytics guy, right? Maybe let's say an IoT expert, okay, quantum computing person. So something people have to identify yourself when you come up after 4, or maybe after you do masters, or maybe when you come up to PhD. Okay, so this is the challenge, okay, for all of you, because these are all very super hi-fi stuff. Okay, but that's why computer science is an opportunity if you are, that means if you are motivated to actually do something good, because there are a lot of opportunities are there. But computer science is bad for those students who only feel that, okay, getting a computer science degree will make my life very smooth. No, that will not happen, because for that level, so many students you have to compete. So many students are just getting computer science degree for the sake of computer, just getting a level of computer science, without getting into any of these deep technological thoughts. I don't want to that. Okay, at college you don't expect to get into the real thing of those deep technologies, but at least you have to have the basics, so that you can understand when you are given a work in this particular technology. When I give you a work in quantum computing, or when I give a work in computer vision, or I give you a work in LLM, right, you should have the basics, right? Basics clear in terms of how the algorithm converts to a program, how the multi-thread programming works, how the memory is handled, right? How the basic mathematical, that means how the mathematics of the kernel functions work, right? All these things you should be very clear. Then I can take you to those particular directions, right? Where any expert can take you, either in a industry or in a research. Okay. So, but if I cannot take you to that level, if you are just a programmer, right, then your life is very tough. Okay, because you don't have the capability to rise to that deep tech levels. Okay, so that way you should prepare. All of you who are doing this, who are in this particular good institute, should prepare yourself in such a way. Baselines are so good, right, in mathematical fundamentals, algorithmic fundamentals, the basics of computer science in terms of maybe database, networks, okay, algorithm, computer architecture, which we say software engineering, which we say these are the fundamental courses. Okay, programming, data structure, algorithm, computer architecture, okay, database, computer networks, okay, software engineering, okay, these are the fundamentals of computer science. You need to have these courses to be finished maybe within, those who are 3-year students, I hope they will finish within 2 years, and then they will go in the 3rd year, they will go with some sort of projects or some sort of deep tech type of things. The people who are in the 4-year BSc course, they have a little bit easier life because they have 1 more year to work on the research, and they can concentrate on this 3 years fully on basic and some advanced courses, and they can really go for a very good research in the 4th year. Okay, so but I think 3 years will coming out soon, so they can test the success sooner. 4 years will be coming up later. Okay, but I think this is a very good scenario for the computer science students, right? Who have lot of requirements comes from industries and research labs to me and the people like me from different organizations in the state or in the city. A lot of requirements comes for good students. Okay, fine. And those who are 4 years BSc, they can directly go to PhD. Fine. Those who have joined as a 4 years BSc, right? Those who are good students, right, and have done a project, they can directly go to PhD in some good institutes, and that will obviously is a really. And I think that people from PhD will, people who want PhD student will prefer your background, than a very normal BTech background. Fine, I'm very sure I've spoken with many of the institutes, and they said that yes, that means a good institute, BSc Computer Science, has a greater, that means has a greater opportunity, right? Or we will prefer them, than a normal BTech getting into the, and for the overseas also. And for the overseas also, the 4 years BSc program is now will do very good, because 4 years, because the previous 3 years BSc couldn't go to abroad because you require a 10 plus 2 plus 4 years of course, right? And so the previous 3 years BSc has to do at least 1 year's course or a 2 years master's program to get directly into the PhD program, right? But I think now the 4 years BSc can directly go to the PhD program, and I think you should target some of you who wants to do research, right, and who wants to do higher studies. They should target, from now on, maybe from the 2nd year onwards, they should try, and they should try to find out what are the things I can get into those, so any questions from the students on that means how they should the plan and motivate? Because I give this, and so one thing I want to say, that one question I want to throw. So what is easy and what is hard in your that means as far as your that means it's a concept or something you have to implement or design, right? What is easy and what is hard? Who can answer? Kothin ki সহজ কি বাংলায় বলছি, what is easy and what is hard? Yes, please. No, if you understand, why you cannot implement, there may be a resource, there may be a resource constraints, maybe there, but that is not your hardness, that is you don't get the support, right? Okay. So any answer? Why I'm asking this, because students sometimes comes to me and tell that, sir, this is very, very hard concept, sir. Because normally my students know that whatever things I deal with, they are little bit hard things. Not so easy things. So yes. So why that means what is the thing that make the things hard for you? Yeah. বাংলায় বলো না, কোনো অসুবিধা নেই। Fine, so let me tell the answer. So if you understand the thing very well, then it is very easy to you. Right? If your understanding is not there, then the things are completely Hebrew, we say, right? It is not there. So those are the hard things which you don't understand, right? So now only the effort what you have to take is that you have to take effort to understand the things. Okay, so you can see that some concept is very easy for someone, right? And something is very hard for someone, because the person who understands that, right, is very easy for him or her. Right? Person who doesn't understand, right, it's a tough thing for him or her. Okay, so the thing is that, right, and that means again I say one particular thing that, okay, suppose 5 rupees drop from your pocket, okay, what you will do? Okay, you will search this particular room. Suppose you just get out of this room and just you find that, okay, I have lost 5 rupees from my pocket. Okay, so you just search this room. Okay, and if you don't get, okay, 5 rupees, no problem. Okay, right? If 50 rupees gets lost from your pocket, right, then you will go up and down in the stairs of the college. Yeah, I will come to that. Yeah, one answer. So 50 rupees, you will just make a good effort to actually run up and down and look into the stairs, right? If 500 rupees, okay, lost, right, then you will go to up to the entire campus of the college and try to find where it has lost. Okay, 5,000 rupees lost, you may actually search the entire city, call the police, all the things, right? So the issue is that the effort you take in your life depends on what value you give to that. Why I'm comparing this? So 50 rupees is a direct value I am telling. So 5 rupees has a smaller value, 50 higher, 500 higher, 5,000 higher. So this rupees is immaterial. It is the thing, that means what you give value in your life. Right? So if you give value in your life, a particular thing that, okay, I feel that this is the thing what I have to achieve, right? And in my life I give a highest value to this particular achievement, then you can do anything. Then time is not the factor, resource is not the factor, right? You can still achieve a lot many things. So the thing is that you have to. So when a student comes in a very casual way and tells us, sir, I don't know when was the exam date, sir, what was the course says. So I tell that what you are not giving, you forget about giving the value to the university, value to the course. You are not giving value to yourself. You are a person, right, who are supposed to get a degree, right, in computer science, right, after 4 years, and come up with some sort of parameters or some sort of attractive parameters. Right? As you are not giving your value to yourself, okay, so when you come out, you will be just like a very normal person who doesn't look like a computer science knowledgeable person. Okay, so what it means that you are not giving value to you, so forget what others will give value to you. And you grow in life. Growing life doesn't only means money or position. Growing life means that means what level of mentality you achieve. Okay, what is your mental condition is actually the growing in life. So that your mental condition will be good if you find people gives you value. Value doesn't mean again paying some money to you. Value means respect. Okay, if you are respected, right, your mental esteem is pretty high, and you get respected because we are in the path of knowledge path, right? So if you have knowledge, right, you will get expected. But knowledge is very hard to acquire. It is not absorbed casually. Casually, any good thing cannot absorb. So one question. I just was in St. Xavier's College, I think 3 days ago. So after my talk, okay, a student gave that means a very beautiful question. Sir, that means I said that you try to learn the mathematics of the models, try to understand how the kernel functions works, right? And when you try to tell the research, you have to do some contribution in the model itself. Okay, it's only running the model on a data set and telling that, oh, it worked. It is not a research in that. Okay, it may be a good project, but it's not research. Research means new contribution to the knowledge domain. Then sir said that means okay, sir, won't you give any value to a person who is just taking our data, running a model and something? I say that when you go to a dinner, right, there are different menus. Okay, first it starts with a chaat masala or a fuchka, right, or a sort of dahi bada, which is very tasty, which you can quickly consume. Okay, but with that you start, but ultimately you have to finish the dinner, because if you only go away of the dinner by taking the chaat masala or fuchka, you will miss the good food which is there. Rice may be there, fish may be there, good curry may be there, meat may be there. So, okay, you can start with just trying up models and testing the data, that's okay. But if you don't actually get into the models, you will not get that food. If you don't get that food, you will not get that particular knowledge. Okay, that knowledge is missing from you. So you haven't tested a good food. So that's the way knowledge develops. There may be some surface knowledge which you have to first acquire, but you have to get deeper because that is the first part of your course. You have to go to second, third, and fourth so that your stomach is fulfilled and similarly your knowledge is fulfilled, right? And then your dinner or lunch is complete. So that mentality you should have in your thought process that I have to acquire this knowledge, right? It's not that I will just have a surface on the knowledge, okay? So I end up my motivational lecture here. If you have any question, I can answer. I will just give so my actual technical talk will be a little bit, I think we are in shortage of time. So I will just give a very very brief thing what I am trying to put to all of you, okay? So this is obvious. One question, yeah, please. Yes. বাংলা তো বলতে পারো যদি তোমার if you are fine with Bengali.
First year student. Now should I explore the fields or should I go for the what is booming right now in this computer science?
You should be thorough. A lot of things will be changing. So when you come out after 3 years, 4 years, a lot of things will be changing, right? Give a very focus on the mathematical components, the coding components, algorithm components, and architecture components. Because why? Because that means I was just back from the very good conference, VLSID. The VLSID is one of the top conference in the country and also in the world, right? Everyone is now bringing AI closer to the system. So when we execute AI from the top application layer, that lot of goodness and lot of what I can say, lot of accuracy or lot of that means in terms of speed of execution we lose. Now people are bringing AI closer to the system. Okay, they are making the computer architecture oriented towards AI because our normal ALU, right, with just addition or multiplication is not so close to the AI which actually does the weight multiplied by inputs and then they accumulate fine okay some accumulation, some spiking function, right? So those things are now coming in the architecture itself. So if you at least understand the basic processor architecture, basic processor pipeline, those are very important for you to learn at this particular level. Right? Any processor pipeline, how it works, any instruction set, how it gets executed, right? How I can form an algorithm. What are the recipes I need to do algorithm? And you have to write multi-threaded programming. Because now you have systems which are supporting multiple cores. You have systems which have GPU. Okay, so don't use single-threaded programming now. Okay, so these are the stick to basics as first year. Okay, second year, you go to some of the advanced concepts. From third year onwards, you can actually look into some of the very deep tech stuff. Yeah.
Thank you, sir.
Okay, so let me start my lecture. Okay, that means I will try to finish maybe 10-15 minutes due to the scarcity of time, right? Rest you can all come in my lab and you can discuss more, okay? So this is what is the quantum intelligence. So quantum computing is coming, that means already there. When I started quantum computing research in Indian Statistical Institute in 2005, right, we didn't have the quantum computer, right? So my supervisor, Professor Shushmita Shurkole and myself, we were just having something in our thought that, okay, these are the quantum computer can be, this may be some of the blocks of quantum computers, so let's try to improve some of the blocks of quantum computer. But when you are now here, right, at the students at this particular 2024 in any of the batches in computer science, okay, so now physical quantum computer is there. Okay, I think some of your batchmates will be visiting a physical quantum computer which is now coming up in Kolkata only. Okay, Kolkata TCG Crest is coming up with a 5-qubit quantum computer, and we have an invitation to visit there very soon. Okay, so IBM has already announced they have a 1,000-qubit quantum computer. Rigetti has a physical quantum computer, right? And many of the Delft has a physical quantum computer. So there are lot of places are there, a lot of infrastructures are there who are really build a physical quantum computer. And CDAC in India is trying to build a physical quantum computer. I am very much in that particular activity with CDAC. Okay. So now what is happening in the computing when we tell quantum computers, right? This is the scenario which is happening. Okay. So we started computer, which were, if you go back to around 1960s or 1950s, 50s or 60s, there were something called electromechanical computers, which were relay-based computers, and then came the analog computers. Okay, recently, if you look, one newspaper article came that Professor A.K. Chaudhuri, okay, who was the professor of radio physics electronics department of University of Calcutta, started the computer science department of University of Calcutta, and in his name, our department, School of IT, was instituted. Right, he was the first person who developed the analog quantum computer, that means analog computer in our country. There's an article very recently came. So now, from that particular age, it came to the age of silicon. Okay, from the valve diodes, from first the relay computers, then the vacuum diodes computers. Okay, and those analog computers, and then came the transistor-based computers, that is silicon transistor-based computers, which is somewhere in the middle, right? And that is on silicon. So on silicon gave with the years, right? It gives a huge amount of dimension reduction in transistor size. Okay, can anyone tell what's the size of the present transistors? What Intel is coming up with, right? Or AMD is coming up. Intel and AMD are the two big players of processors, right? They design processors, okay, general purpose processors. Okay, so what's the size of transistors? Any idea? All the silicon chips we use. It's of the please. Very good answer. Yeah, 3 nanometer is already there, but I think hardly there are any chips available. So chips you will mostly get in 8 nanometers. Okay, that means larger to that 14 nanometers, then 22 nanometers, 45 nanometers, 60 nanometers, 90 nanometers, 180 nanometers, 120 nanometers. When I basically started my career as an EDA engineer in ORCAD, which is now Cadence. Okay, 1998, 1999. So when I started working in Cadence, our transistor feature size, can you guess what was the feature size? It was 480 nanometers. So from 480 nanometers with 20 years, we have come to around 3 nanometers, which is exactly following the Moore's law. Okay, the size becomes half in every 18 months. Okay, number of transistors gets doubled in every 18 months, whatever you say. Okay, it follows the Moore's law, but we break the Moore's law when we go to this scenario. So now when we go to a 3 nanometer transistor, we are already hitting the 1 atomic layer transistor. So the transistor itself is now 1 atomic layer. So now the question is whether we will still continue to do with transistor, or we try to see that whether we can use the atomic state or subatomic states of your matter. Because if we hit that, then they are governed by different laws of mechanics, which are called quantum mechanics. Okay, still we prevail with classical mechanics, right? In the classical transport theory, right? When we see the electron transport theory in our semiconductors. Okay, but now we go to the quantum states. The quantum states are not visible because we are not identifying each individual subatomic particles in matter. We are working with a bulk phenomenon, right? And in the bulk phenomenon, the atomic states gets cancelled out, and we cannot see the real quantum transitions. Okay, so fine. And what is computing? Can you tell very, very simply what is computing means? Yeah, please. Yeah, so this is user's perspective, but from system perspective, it is a particular system which can update its memory state. That's all. Right? That means so how it will update its memory state in different cycles of operation, that is given by the program logic. Okay, so program logic actually tells you that means how the memory states will be updated, and you start with a particular memory state, which is your which is the initialization state, right? And you end at certain memory state, what is your readout state of your computer, right? And in between, it is just you have to update the memory states. So now any computer systems, a computer system I can develop if I have a mechanism to represent data and I have a mechanism to update the data in a controlled fashion. Obviously, because you require a program to update data. Otherwise, it will be a random data. Okay, random process. Okay, right? You need to a logical process, which means that your memory states will be updated based on a particular flow, right? On a particular data flow or control flow, sequence. So now this is what is quantum computers. So now can we devise a technology where we can represent memory states by the states of these subatomic particles, right? Okay, and then are their operations enough so that we can actually change their states, right? If you can do that, then we can tell that, hey, we have found a different type of computing technology, right? Obviously, we will go to that investment if there is an advantage. Okay, if there is no advantage of what we are getting now, right, why I will go to, okay? So come back to this maybe within the next 2-3 minutes. So this is what is a physical quantum computer. Okay, if you look, this is a physical quantum computer. Your quantum chip actually resides here, right? And a lot of your channels, cooling channels, a lot of your interconnects comes, but now it is getting smaller and smaller. Okay, this is a IBM quantum computer maybe 5 years ago or 6 years ago. Okay, if you see the present quantum computer, it is much more compressed. Okay, people are enhancing the technology so that the wires are all getting very within the chip instead of making so many wires outside the chip. Okay, so that's the thing. Okay, sorry. So when we say quantum computer, obviously we have to explore or we have to leverage some of the inherent quantum principles. Okay, quantum mechanical principles, right? And they are actually, duality is one of the things which we know that from the duality we know that the particle can produce interference, because interference is a wave property, right? So particles at this level of matter can interfere, right? Because these are not particles, these are basically waves. Okay, so we have interference, we have superposition, and we have entanglement. These are the three things which are never found in classical domain of matter, and can only be found in the quantum domain of matter. And if you can exploit this to do some useful computation, and we can show that there is some betterment, enough betterment, then computer scientists will be interested to use this as these systems for computing. Okay, so let's see how it works. Okay, so now if we look into this scenario of the memory state, because again I say that the memory state is a very important part in entire computing, because ultimately a user only sets a memory state at the initialization memory state, and user reads the memory state, right? User cannot actually get into the computing process. Okay, fine. So the memory state, what we do in a particular classical system is called a bit, right? So the bit can have two values, any bit. Okay, one is a high, which is logic value 1, logic state 1, and one is low, which is logic state 0. Right? Whereas a qubit, okay, can also have, obviously the two values are there, 0 and 1, but a qubit state, okay, this is a very unique type. This particular sphere is called a Bloch sphere, and the Bloch sphere has a radius of 1. Okay, why radius of 1? Because any vector from here, it touches the surface of the Bloch sphere, represents a quantum state. And the Bloch sphere has 3 axes, x, y, and z. So the vector can rotate across, x, y, and z axis, right? And can change its states. Okay, so what I said, right? I said that if I can represent a data state, and if I can do an update of the data state, then I can do computation. Okay, so the update of this state is very simple, right? In the case of a quantum computer, because because any of the vector states which are on the surface of the broad sphere, right, are that means, okay, they are called superposed states, right, and they are defined in combinations of the two basis states. In a simple case, if you are going for the z basis, so this is the z axis. If you are going for a z basis, the decomposition will be in terms of 0 and 1. Every state has a composition of 0 and 1 state in the z basis. Similarly, if you are going for an xy state, which is this and this, sorry, the x-axis, which is this axis, right? It goes with a basis which is actually 0 plus 1 and 0 minus 1 basis. So it has a composition, that means any of the vectors can be also represented on the x-axis, on the x basis, with a combination of 0 plus 1 state and a 0 minus 1 state. Okay, so they are called, okay, these are called up and down state, right? And these are called this type of states. Okay, so this is also one of the new thing in quantum computer, that the state is defined in terms of the basis, right? And this is very important when we go into the quantum cryptography or quantum communication, because in normal cryptography, what we do, we actually encrypt our data, right? We actually jumble up our data, okay, so that anybody takes the data cannot make out what is there. Okay, the message is jumbled up. So, okay, ciphering the message means you use a key to actually jumble up the message, right? And that means any if cannot get it. In the case of quantum, it is not only the data, you also have to know the basis. So if you measure a quantum state in basis x, that means, and if you measure the same quantum state in basis z, the values will be different. So it is so difficult to actually get information out of a quantum state. So you have to know what is that means. Okay, that means you also have to know the basis of measurement. So actually, in the case of quantum communication, a public channel you can use for key exchange, because your bases are random. So with a random basis, you can generate a random string of data, because basis is so important in the quantum. Okay. So in terms of technology, how these quantum states are defined, there's a different types of different technologies supports different type of qubits. Okay, but though the most stable is still the superconducting qubit, right? And photon is the optical quantum computer. They uses the photon polarization states, right? The superconducting qubit, that means, works in the direction of the current. In a superconducting loop, there is a magnetic field, and the current movement of the current gives the qubit, right? And the others are, okay, people are working on the spin of atomic nucleus, which is basically ion trap and all these things people are working. Okay, so there are different types of technologies, and okay, different. Okay, so now this is another very important thing. So two important things are shown here. Okay, so as I said, that if a vector is here, it can be decomposed into the two bases. So it is this is a pure one vector, but this is a superposed vector psi. Okay, and now you can tell that. Now the difficulty here is that, okay, that when you try to measure this vector, okay, this vector will collapse either here or on 0. So when you measure this, it will be either recorded 0 and 1. Depends that what probability is there. What is the decomposition coefficients, right? If it has so the equal decomposition means 1 by root 2 for 1 and 1 by root 2 for 0, and then there is completely random. So you measure once, you will get 0, and then measure one again, you will get 1. But you can also make a little bit different. Okay, you can make the amplitude of the coefficient of 1 a bit higher and 0 a bit lower, or vice versa. Then the probability of getting it in 1 will be higher, or probability of getting 0 will be higher. So this is what actually directly leads to the concept of measurement, and this directly leads to the concept of the classification, what we do in machine learning. Okay, so what we do in machine learning? In machine learning, we try to, there are levels, and we try to assign the probabilities of a particular feature vector, right, one of the levels, so that you can tell that if this data is represented by this feature vector, right? And this feature vector aligns with this label maxima. So we do softmax, right? So in softmax we give a probability, right? So if we actually try to make a probability of this particular class for this particular feature vector, this becomes high or low. So this measurement orientation directly can give you a sort of notion that what I can do when we have quantum states representing the feature space, and then with some operators, that means as it is a learning paradigm, that means as a supervised model. In a supervised model, we know that this particular vector, this particular multidimensional vector, right, is of level 1, and this multidimensional vector is of level 0. Simple binary classification problem. So you know that. So what you can do, you can make a quantum circuit which can automatically take this multidimensional vector, and multidimensional vector is very easy to represent in quantum. Why? Because more and more qubits you take, more and more space increases. One qubit can give you two features. One is dependent by the 0 basis and one is 1 basis. 2 qubit can give you 4 features. So the number of features you can represent is of the order of 2 to the power n compared to n qubits you invest. This is not there in classical. Classical is linear. Number of features you have, right, and number of components you have is linear. Here it is the exponential. So you can represent a larger feature space with a lesser number of qubits, right, to work with, because this is the thing. And then what you do, as it is a supervised learning, you can use or you can train your quantum circuit so that when these vectors are measured, the probability of level 0 is higher, and when these vectors are measured, probability of level 1 is higher. And if you can make this quantum circuit, right, the quantum machine learning works very fast. So that's where superposition, interference, measurement helps. The second one is entanglement, what I shown here. Entanglement is directly used in communication. So in communication, what I do, in communication, I try to generate a message and I try to pass the message to the party B with a communication channel. Quantum entanglement is such a thing that if you have entangled two particles and then you take them separated away, then if you measure one particle, you can know what is the content of the other. Either the content is same, depends on what type of entanglement you have done, or the content is directly opposite. You can just take a inverse of the data here and you can find what is B. Depends on how you have measured this, right? And more multi-bit entanglement you do, more and more multi-party communication you can do. You can pass the same message to more of them, but it is costly. It is technically, it is feasible, and it is not so challenging like quantum processing, but it is costly because you have to have some sort of Bell state generator which will generate the entanglement among multiple particles. So you have the same Bell state generator which will actually be used to make a multi-party entanglement. And if you can do that, then you can communicate with all of them without actually doing much effort. So I think I will stop here due to the time, right? I think there's not much time. I will close. So there are a lot of things that there. Status of quantum computing is very promising. You see that all the big giants are doing this. IBM, Microsoft. Actually, good point is all my students who have done quantum computing, they are all getting into good industries or good postdocs. So this is a very happening domain, right? All of you should actually take efforts to go through that. And right, we have done these are already the IBM is a good to follow, right? If you are doing quantum computing, IBM is obviously good to follow. NVIDIA is coming very strongly, in quantum computing. These are the two platforms you are coming. Amazon is there. Amazon is also very strongly coming in quantum computer. You have the Amazon Bracket, right? The NVIDIA CUDA Quantum, right? IBM Qiskit. So all these three are very strong cloud verticals where you can actually run. IBM gives the physical machine, right? NVIDIA doesn't have the physical machine. They only give the simulations. Amazon gives physical machines from multiple parties. They have IBM, they have Rigetti, they have Pennylen, all multiple quantum systems they can offer. Okay. Yeah, so a lot of things are there. We have the quantum machine learning is now the buzzword. I just given a little bit example to you that how this is not so easy because okay, these are called parameterized quantum circuit. How you try to take it from the input state to the measurement state. In between, parameterized quantum circuits comes up, and these parameters may again be optimized using classical. But you have to remember that when you do this is your training phase. Okay, that means in your actually execution or inference engine will be pretty fast because you can take the inference over a large amount of data at one shot, which the classical computer cannot do. Okay, so these are all. That means we have a lot of things at them. Just keeping we have got the IBM researcher access award, the first in India due to this algorithm, which was developed by my student Mrityunjay. He is now the principal engineer okay, for HCL Technologies in quantum domain. So we developed the first quantum ant algorithm, right? The full quantum ant algorithm. Okay, it is a big story. I will not come to that story. It was a big, long, okay, what I can say, long collaboration with IBM, which ultimately resulted this particular thing to work out. A lot of applications are coming up in optimization, logistics, finance. Okay, new domains are coming up. IBM has given a very beautiful landscape. 1,000 qubit already they have announced this, and they have a target of 5,000 qubit by 2025. Okay, so let's see how it works out. We have very good quantum computing researchers, but as you know, university, what happens? A bunch of researchers join, they do fantastic work, and they leave, right? And then the next researchers join. So now we are in that phase. Some of your students are also helping that particular point, that they are also coming as interns and joining my group, and new PhD students are joining. Right, we have strong collaboration with NVIDIA, IBM, Amazon, CDAC. So you can, who are interested, you can work. We have a startup also, QRD Lab. Actually, Shayan, who is your ex-student, is now one of the director of this particular QRD Lab. It passed from one series of students to the next series of students. Okay, so QRD Lab is a startup from our group. Okay, so thank you. So due to the limitation of time, I restricted my talk. A lot of things are there. Maybe 1-2 hours lecture one day will be good. Yes, any questions? Yeah.
Abraham, do you have any questions?
Little bit, I think. New topic, very new topic, I understand. Very new topic, but there's a beautiful lecture series you can go through. The David Deutsch of Oxford. A very beautiful lecture series. You can listen to that. Okay, quantum, okay, very preliminary of quantum computing. So they have started working with this GPU, right? You have started, right? They will now work with NVIDIA team, and they will also start work with NVIDIA team very soon. But they are working with a different problem. They have a different problem. A lot of resources are available, right? In our university, ISI is also have a group, right? And the bigger group works in the CDAC. CDAC Bangalore does the entire software stack. CDAC Pune does communication and system integration for quantum hardware. HPC, quantum HPC is done by CDAC Pune, right? And CDAC Kolkata and Patna is also coming up in some way. So IBM announces a lot of these contests time to time for students. You can go into that. But having said so, quantum computing is not the only domain. You can get into computer vision, large language models coming in so good way. IoT is coming in so good way. Right? We are organizing an annual IoT conference. We have just started this year. That is AI for sustainable agriculture, which is basically IoT, robotics, right? AI, okay, to support smart agriculture. So next year also conference will happen. This is collaboration with CDAC Kolkata and Patna. So maybe next year also we will do the same conference. So you can also focus on AI for sustainability, that involving IoT. We also have a good IoT lab in our department. Okay. Security is also very important. Security, cryptography, crypto analysis, these are also very important domains. Because a lot of domains are there. It's not that because due to time I have to speak on quantum computing, but a lot of things are there you can work with, right? But you try to work, try to keep yourself engaged. Don't be sitting idle. Because so many things are there now to work on, right? Okay, so for me, some of my students know that when I tell them what is your hours of the day. If the student comes with tells at 24 hours, I say it's wrong. You have to make 48 hours. Okay, so your day should be 48 hours. So whatever normal people do in 24, okay, that means you have to do double. Okay, then only you can excel. So that you have to try to manage. Okay. So 24 hours duration, about 48 hours work. Okay, please. So thank you once again. Yeah.
Thank you, sir. Now we are at the very end of this beautiful informative session, and I would like to end this session with a vote of thanks. It is my great pleasure to present a vote of thanks of the seminar towards quantum intelligence addressed by Professor Amlan Chakraborty, Professor and Director A.K. Choudhury, School of Information Technology, Calcutta University. Thank you very much, sir, for delivering such important speech. In his speech, he mentioned computers are progressing in a very fast manner. We are introducing more important subjects in our syllabus. Computer vision also getting now new dimensions. He also mentioned that the most important challenges is you have to learn more and more. Students need to upgrade themselves continuously. More importantly, few courses like database, networks, architecture, algorithms, basics of computers, these are the most important topics you should cover properly. Now, students can join in PhD program after completion of their graduation. He also mentioned the process how student can develop their knowledge. He also mentioned about quantum computers already introduced by IBM. He discussed the present size of transistors, which is in one dimension layer. His speech on qubit will be very much helpful for the students. I would like to thank our principal Maharaj for the whole arrangement, and I also like to thank our fellow faculty members of their efforts to make this event possible. Last but not the least, I like to thank our beloved students for their active participation in this session. I sincerely thank each of everyone here for making this session a success with this gracious presence. Thank you very much.